Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Abdul Karim and my metric number is CD200222. For indoor environmental design, we have picked the topic to analyze thermal comfort at Makmal Ceramic Area 1 Wing H Block G2. Our main subtopic is to creating the comfortable learning environment for student. Our group name is Bintelligent and our professor name is Prof. Madia TS Dr. Azian binti Hariri. For our group member name is the first one Nur Atira Aida binti Nurizan at Nur Jihan. The second one is Muhammad Nizam bin Kamis. The third one is Nurul Atira binti Johar. And the fourth one is Muhammad Hafizul Abdul Karim. And the last one is Siti Sarah Sofia binti Mustafa at Mustafa.
Hi, my name is Naati Raida binti Norizan. So I will explain a little bit about introduction, where we all find about thermal comfort, which is a physiological state of certification with the temperature influenced by factors like clothing, activity level, ambient temperature, humidity, and air movement. And also we find predicted mean void, which is PMV. It is index predicting the average thermal sensation of a group based on air temperature, mean radiant temperature, air velocity, humidity, clothing insulation, and also metabolic rate. And then we find for PPD, which is predicting percentage dissatisfied, which is estimate the percentage of occupant dissatisfied with thermal condition based on PMV value range from -3, which is cool, and until +3, which is hot. And our problem statement in this report, we are find issue at the ceramic laboratory thermal environment may not meet the diverse student preference, where is affecting their comfort and performance during do their experiment. So next is objective assessment, which is our goal is to evaluate and analyze thermal comfort in the ceramic lab to enhance their learning environment. And for our scope of assessment, we are focused on thermal comfort in ceramic laboratory using chemo instrument and questionnaire and adhering to ASHRAE standard 55. And our description assessment, which is our method, is combine questionnaire feedback with chemo instrument measurement of air velocity, radiant temperature, humidity, and ambient temperature to calculate PMV and PPD, followed by analysis and recommendation.
My name is Nurul Atira binti Johar, metric number AD200062, and I will present for literature review part. The chosen location for this research project is the ceramic lab located on the top floor of the G2 building, which is Faculty of Mechanical Engineering building at UTHM. The choice of this site is important for the examination of the thermal satisfaction experienced by UTHM students while their engagement in different activities inside this area. The dimensions of this space are about 61 feet in length and 25 feet in width. In this slide, shown special configuration in this lab. As you can see, at quadrant 1, there is one window and there are walls at northwest and southeast of the quadrant. There are provided 12 chairs. And for quadrant 2, there is no window. There is wall at southeast of the quadrant. There also provided 16 chairs. While at quadrant 3, there is no window, but there are walls at northwest of the quadrant. And lastly, for quadrant 4, as you can see, there is no window, but there are walls at northwest, northeast, and southeast of the quadrant. There is also whiteboard at the northwest, and there's also provided 16 chairs.
Assalamualaikum. Let me introduce myself first. My name is Muhammad Nizam bin Kamis. My matrix number is CD200232. So I would like to present about the methodology. So for the methodology, thermal comfort data is collect through survey and chemo equipment. So, combining subjective perception with objective measurement, survey gather feedback on temperature sensation and preference, while chemo equipment measure environmental variables. So, for the questionnaire methods, collect data from occupant voting in the ceramic lab according to age, gender, height, weight, clothing, occupant location, and thermal sensation scale, and also activities. So while chemo tools method measure environmental variables such as air temperature, relative humidity, air velocity, and mean radiant temperature. Then I will explain further about the implementation through the survey. At the first is gender. Gender can influence the in metabolic rates and thermal comfort preference. Then second, age. Age can affect metabolic rate and thermal sensitivity also. Young people can more resistant to cold temperature than old people. So go next to the height and weight. While height and weight variable like height and BMI affect heat rotation and dissipation, with taller individual feeling warmer in cooler temperature and lower BMI values indicate less insulation. So the preferable temperature, the survey asked respondents about their preferred temperature by using the thermal sensation scale, enabling them to select the most comfortable temperature, thereby optimizing thermal setting and enhancing comfort and satisfaction. So this is the X-ray standard thermal sensation scale. Zero stand for neutral and negative one stands for slightly cold. Positive one stand for slightly warm. So occupant can vote their rating according to this scale. So the survey involve occupant rating their thermal sensation on a scale of hot to cool, comparing their preferred comfort level to the one they experience in a specific quadrant to determine consistency with Asia standards. Next, the questionnaire have the question about the clothing. So, the clothing is to understand clothing choice impact on thermal insulation and comfort perception. So, according to this table, so they have their rate for their own clothing, such as cap, beanie, kopia stands for 0.2 CLO, and hijab stand for 0.4 CLO, and so on. So, respondent garment insulation is estimate using X-ray 55 rating and publication. Lightweight, breathable textile release heat in higher conditions. So through survey have the occupant location also. So for the occupant location, they have the four quadrant, which is a near wall, near window, at the middle of the lab. So the occupant can choose their specific specific location at the lab. So they can vote their preferred thermal comfort at the position. So this is the last implementation through the survey, which is the occupant activities. So regarding the primary activity, they engage in within the lab during the assessment period. The purpose of this question is to differentiate the main activity as it has implication for assessing the metabolic rate associated with each individual activities. So according to this table, as we can see, for the activity C stands for metabolic rate, which is 1.0 MET. MET is the unit for metabolic rate. Then standing relax stand for 1.2 MET, and light activity standings for stand for 2.0 until 2.4 MET units. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Siti Sofia. I will discuss about the equipment of Chemo Army 310. So this is equipment called Chemo's Army 3120. This is function to measure device designed to simultaneous assess various parameters, making it an invaluable tool for various application. This application can be measured, which is air velocity, um, mean radiant temperature, humidity, and ambient temperature. Here is the our parameter to collect our data. So first, air velocity. Air velocity is function to use a hardware that is an environment of constant thermal equilibrium. And second, mean radiant temperature. It is used to determine how hot or cold all the surface around a person are on average. For humidity is to measure how much moisture exists in the air. And let's see ambient temperature. This is the temperature of the air in each space. It is one of the most important things that thermal comfort study look at. And lastly, our location spot for chemo equipment. So as you can see the figure, point one, the spot is 1 meter inward from the wall and window, near one chair and between two rectangular lab table. For quadrant 2, 1 meter inward from wall near one rectangular lab table with equipment lab. And third quadrant at the center of the quadrant between the lab table. And lastly, fourth quadrant is 1 meter inward from the wall at the middle of class in the lab and between two chairs. From me, thank you.
So this is our result and discussion in our report. We are focused the data collection. We are reveal the significant insight into thermal comfort, and then we are compare the thermal sensation reported in the morning and evening. We are noting variation based on individual physical characteristic and clothing choice. This highlight the importance of considering personal factor in evaluation thermal comfort in different environmental settings. So next for our thermal comfort certification survey analysis, we analyze the thermal comfort certification survey. We use the thermal sensation vote TSV in line with ASHRAE standard 55 in using year 2013. This helps us understand the general thermal sensation and demography of participant. Factors like BMI, clothing, environment condition play a crucial role in determining certification level.
Next, for the result obtained here. So the analysis thermal sensation obtained from the questionnaire with those from the thermal comfort, considering each factor, situation, and quadrant. So from the questionnaire, we have emphasized to evaluate 10 voting of resident only in the ceramic laboratory according to the thermal comfort in the morning and evening by analyzing resident voting based on gender, location, and experimentation. With this table showing occupancy voting for thermal sensation at specific moment. So if you can look at the table here, we have four quadrant, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So the SC meaning is for slightly cold, and N is meaning for neutral, SW is meaning for the slightly warm. So we have two activity here. Sorry, not two activity. We have two condition here, which is morning and evening. So we have gender, location, activity, and also for the evening is the same for evaluation. So for the gender, we have male and female. For the location, we have near window and near wall. For the activity, we have seated, standing, relaxed. So and last one is light activity standing, which is same for the evening event. So 2 person voting at quadrant 1 in the morning, and 2 person voting at quadrant 2. And then for the location, 1 person has voting for near the window, and 2 person has voting for the near wall. And for the activity, there is 1 person that standing or doing their activity at quadrant 1, and 2 person has doing their activity at quadrant 2. And then for the evening, 1 person at quadrant 1 for gender, and then 4 person at quadrant 2 for gender, yes. And then for location, we have near window there is one person that doing their job at quadrant 1, and then we have 4 people that doing their work at quadrant 2, which is near wall. And the last one is activity they do, which is they do at seated position. We have one person that in quadrant 1, and then we have 3 people that doing their activity at quadrant 2, which is 2 person is doing their job while seated, and then one person doing their job with standing relaxed, and last one is one person that stand doing their activity which is like activity standing. So that's all for me. Thank you.
So next, comparison average of data obtained from Kimo tools with standard and guidelines. This is subtopic from point 4. So we only cover about data collected from quadrant 3. We only explain one example. So to more detail about explanation, firstly we look at air velocity, which is the measurement show considerable variation ranging from 0 meter per second at the sample 2 and 3 to 0.19 meter per second at the sample 5. This resulting in average air velocity of 0.09 meter per second. This indicate overall low air movement with some area experiencing moderate airflow. Moving on at temperature, the data is quite stable, fluctuating slightly between 24 degrees Celsius and 24.1 degrees Celsius, with the average temperature of 24.09 degrees Celsius. This suggests a consistent thermal environment within quadrant 3. And in terms of relative humidity, the value are fairly uniform, ranging from 73.5% to 74% with an average of 73.78%. This indicate a consistency humid atmosphere throughout the quadrant. And lastly, the ambient temperature, which is show minor variation ranging from 24 degrees Celsius to 24.5 degrees Celsius and average 24.16 degrees Celsius. They reflects a stable thermal condition with a slightly increased absorb at the sample 5. So in conclusion, the data from quadrant 3 is highlight stable temperature and humidity condition with low but variable air movement, ensuring a consistent thermal environment. This analysis help us understand the microclimatic condition and can guide improvement to enhance thermal comfort in similar setting.
For the conclusion, the data collected through the questionnaire and Kimo instrument demonstrate that while the air temperature and all quadrants remain within the tolerable range, there were discrepancies in the air velocity and relative humidity leading to instances of discomfort. Particularly, quadrant 1 and quadrant 3 exhibit higher air velocity, whereas the quadrant 4 experienced minimal air movement. The humidity levels were consistently higher than the accepted range, especially in quadrant 1. So the result highlighted the need for target improvement to enhance thermal comfort in the laboratory. Will be addressed. The visibility in air velocity and reducing humidity level are crucial steps. Additionally, considering individual preference and specific activity performed by the occupant can further optimize the indoor environment, thereby enhancing the student learning experience and overall satisfaction is a crucial. So in conclusion, creating a comfortable and thermal environment in ceramic laboratory is vital for maintaining the well-being and productivity of the student. By implementing the recommendation change, it is possible for us to achieve a more stable and agreeable indoor climate that caters to the diverse need of all occupants. For the recommendation, To improve the air movement, it is recommended to install additional ventilation systems such as fan or exhaust system to address the low air movement in quadrant 4 and to ensure the consistent airflow throughout the laboratory. Regular maintenance check on existing HVAC systems should be conducted to ensure they are all functioning efficiently and to adjust setting to balance air velocity across all the quadrant. For humidity control, installing the dehumidifiers in area with consistently high humidity, particularly in quadrant 1, can help maintain the humidity level with the acceptable range. Additionally, enhancing the insulation of the laboratory can prevent external humidity from affecting the door environment, providing the occupant with the ability to adjust thermostat in different zones of the laboratory can cater to the individual thermal preference. And the last one is encouraging flexible clothing guideline will allow the student to address according to their personal comfort while maintaining safety standard in the laboratory. That's all from us. Thank you.